All right, welcome back, guys. So this one gonna be quick. Says we're gonna talk about just a little bit of intermolecular forces, or short IMF, right here. Okay, so there are a few main types that you're gonna see. So we have ion dipole interaction. Right, we got a hydrogen bond, which is exactly like dipole interaction, but it's super dipole, Superman right there. But it's stronger than a dipole, so I call it super dipole. Right, we have dipole interactions. And the weakest one, we have London dispersion forces. All right. So for the polar compound can do the top three, and the non-polar compound can do only with London forces. All right. Now let's get into the detail real quick. So just hydrogen bond, dipole, and London dispersion forces. Okay. Start with the dipole. So let's say acetone right here. We know that they are polar solvent, polar compound. So oxygen is partially negative, carbon partially positive. They are negative and positive. They attract. There's a dipole. So two polar group, two poles. Sorry, one pole. I mean, so dipole interaction. Same thing with the diethyl ether, right? Dimethyl ether. So carbon partially positive, oxygen is partially negative. So attract right there. Okay. Now, hydrogen bond is exactly like dipole interaction, but it's stronger, super strong. And this is how it works. So, for example, ethanol, OH bond right there. So, the difference in electronegativity is higher. So the partial charge is larger than the one in dipole. Okay, they can form dipole interaction right here, right? But it's stronger, so we call hydrogen bond. Right? If you look at the boiling point, ethanol is 78 degrees Celsius, right? In acetone, 56, and dimethyl ether only 35. This guy have the high boiling point there because the interaction right here is really strong. Okay. Now the question is, how do you know which molecule from hydrogen bond? That's why I have you memorize this mnemonic right here. First, organic chemistry, neat, verbal, and short. Hooray! Okay. So the top three except chlorine. This guy can form hydrogen bonding. Now this guy can form hydrogen bond. And why is that? Well, because this guy are the top three highest electronegativity. When it pair up with the lowest electronegative atom among non-metal, the difference in electronegativity is large. The charge right here is large as well, larger than the regular dipole. Okay, so this from one molecule, OH from one molecule, and oxygen from the other molecule. All right, so that's from hydrogen bond right there. All right, compared to a regular polar bond. Right, so the difference in electronegativity is smaller, so the charge is smaller as well, which means that the interaction between these two molecules right here is weaker than the top one right there. Okay, the bigger charge, the stronger the interaction. Basically, that's what I want to say. Okay, all right. Now, for hydrogen bond, we're going to go to the next video right there.